Hello everyone, welcome back to our course. Next, we are going to introduce CAP theory, which is one of the essential principles to develop distributed NoSQL databases. Simply speaking, it exposes the nature of distributed systems and gives the guidelines for NoSQL design. In order to understand CAP theory, here we give you the backgrounds of NoSQL databases problems. Firstly, we need to say that NoSQL databases are usually designed to deal with a large amount of data. So a single node system is not efficient. Or namely, when the data volume is large enough, a single node cannot store data. In this case, a distributed storage architecture is required. On top of that, to ensure reliability, data shards and replicas may be stored on multiple nodes. Now, here comes the problem. When data replicas corresponding to the same file being stored on different nodes, can we make sure the replicas of all nodes always keep synchronized in real time? To answer that question, people proposed the CAP theory. Here, CAP is a combination of the initials of three English terms. So the first one, which indicates the C property from CAP, is called consistency. It says that data of all nodes is always the same. And the A property of CAP is availability, which says that the service is available throughout the normal response time, or namely, we cannot wait for too long. And the P property has a full name called network partition tolerance, which says that when a node or network partition is faulty, the distributed system can still provide services that meet the consistency or availability requirements. The three requirements describe distributed storage from different aspects, but just as the theory tells us, unfortunately, we cannot build a distributed storage system that meets all the three requirements at the same time. And in fact, in one distributed storage system, we can guarantee two of them at most, while sacrificing one. That is, a distributed system cannot satisfy the three basic requirements at the same time. One system can only satisfy two of them at most. Consequently, we need to pick two out of three, which means that we may have three options. Then, how to make choices? As the background indicates, NoSQL databases are usually designed to deal with a large amount of data, so a single node system is not sufficient. Therefore, the P property is essential, or namely, for a distributed system, partition fault tolerance is a basic requirement. Then, we only need to balance between C and A. Below, we can find some examples. The RDBMS, which stands for Relational Database Management Systems, are usually CA systems. Namely, they are usually developed on a single node machine without scalability. And CoachDB, Cassandra, the MongoDB, and React are common AP systems, which means that they sacrifice overall consistency property, and data on different servers may be different. And MongoDB, HBase, and Redis are usually CP systems, which means that data are always the same on different servers. But if there is something wrong with one server, perhaps we cannot make sure the whole system is still available. And to further understand CAP theory, let's look at a real-world scenario. As shown in the following figure, in a two-node database cluster, the two nodes are located in two equipment rooms and store the same data. At this time, a user initiates a data modification request to equipment room 1. In this case, the two equipment rooms cannot communicate with each other due to network exception, and the latest data cannot be synchronized to the other equipment room. In this scenario, we consider that the AP is satisfied and the C property is lost. To ensure data consistency, if equipment room 1 does not execute the request after receiving the request, the A property is lost. Therefore, when partition occurs, only one of A and C can be selected to ensure partition tolerance P. In most large-scale Internet application scenarios, there are many hosts and scattered deployments. In addition, the cluster scale is increasing. Therefore, node faults and network faults are normal. In addition, the service availability must reach N, nice, that is P and A. Discard C, second choice to ensure final consistency. While there are places where the customer experience is affected, it is not as severe as it is causing the user process. In scenarios where money is involved, C must ensure that no concessions can be made. If the network is faulty, the service is stopped. This ensures that the CA and discards the P. It seems that there have been no less than 10 accidents in the domestic banking industry in recent years, but the impact is small. The reports are not much, and the general public know little. The other is to guarantee CP and discard A. For example, if a network fault occurs, some events are read-only to prevent from error expansion. Alright, that's all for this chapter. In this chapter, we introduced the origin of CAP theory, the definition of CAP theory, and gives you some understanding of CAP theory. Hope you guys enjoy all the contents in this chapter and see you in the next chapter.